So today we're just going to really just be incorporating imaginary numbers and complex numbers into what we've been doing with synthetic division and finding zeros. So what I want you guys to do is do the do number one, and number two is using synthetic division with eyes. It's just making sure you're good with the computations with eyes. That's it. There's nothing really too new with number two. So go ahead, pause the video, and play it again once you're done. So for number one, if I have a 0 at 3 over 4 and 2i, well, if I have a 0 at 2i, that means we also need to have a 0 at negative 2i, because the I comes from the square root, and that's the plus or minus the square root. So our zeros would be, our factors would be 4x minus 3, and then x minus 2i, and x plus 2i. Multiply that out. I would start by multiplying the i's first. And you'll notice the i's cancel out. The 2xi and the minus 2xi cancel out. And the I squared just becomes negative 1. So negative 1 times negative 4 would be positive 4. So then we get down to two factors here. And we can multiply those to get f of x, which is 4x to the third minus 3x squared plus 16x minus 12. So on to number two. Here we're using synthetic division to divide h of x by x minus 3i. Well, if we look at this one, the 0 in this case would be 3i, so that's what goes into the box in the top left. And then we write our coefficients: 2, 1, negative 7, 21, negative 225, and 108. Gonna need a calculator for this one. And now it's the same exact process. We drop down the 2. We write the 2 here. 2 times 3i would be 6i. Add 1 plus 6i. Well, you can't really add those together. They're not common terms, so we have to just do, 1 plus 6i. Multiply that times 3, so you have to do, 3i. Now you have to do 1 plus 6i times 3i, and you would get, well, you can do the math down here. That would be 3i plus 18i squared, which would be 3i minus 18, because I squared is negative 1. Write it in a plus bi form, so it would be negative 18 plus 3i. So it would be negative 18 plus 3i. Add that down. That would be negative 25 plus 3i. And we're just doing the same thing over and over again. We're multiplying negative 25 plus 3i times 3i. And you can do this in your calculator too. Feel free to do it exactly how you see it in the calculator. Write it with parentheses with the I times 3i. And that will help save you a lot of time. So that would be negative 9 minus 75i. Add those. That would be 12 minus 75i. Same thing, 3i times 12 minus 75i. 225 plus 36i. Add those. Well, we're just left with 36i. Now do 36i times 3i. You would get negative 108. And look at that. That is a 0 of h of x, or a factor of h of x. So that's how you would synthetically divide using imaginary numbers. It's the same process. It's just, a little bit more work with the eyes, and just you have to really make sure of your computations. But you can also just plug this into the calculator. Saves you a lot of time. So on the next page, given 4i is a root of p of x, find all the roots of p of x. So think about this for like 10 seconds. If 4i is a root, what else has to be a root? I think I heard it from someone. Negative 4i would also have to be a root. So that's what we're going to use to do synthetic division. We're going to use 4i and negative 4i. So I'm first going to let's do 4i. It doesn't matter which one you do first. So we do 4i. 1, 3, 14, 48, negative 32. And we do the same thing as we have been doing for synthetic division, and much like we did in the do now, We drop down the 1, and then 1 times 4i would just be 4i. We add 3 plus 4i, and we just get 3 plus 4i. Same exact thing as we have been doing. You do 3 plus 4i times 4i, and I can't recommend this enough. When you're going to do synthetic division with i's, it's going to take a lot of time to multiply the i's. That's probably the part that takes the most amount of time. Unless you use the calculator. So please plug this into the calculator. I know we didn't do this when we did the i's, like the first unit, but you want to use the calculator now because I know you guys all can do this. So use the calculator, plug that in the I button in case you don't know where it is. It's right above the decimal point. So you got to press second decimal point, and that gives you the I. So I'd plug it in exactly how you see it right here. And when you do that, 4i times 3 plus 4i is negative 16 plus 12i. Add vertically, you get negative 2 plus 12i. I want you guys to pause the video and just finish out this synthetic division. So this is what you should get for this synthetic division. And now we also know negative 4i is a root. So that's what we're going to do here, negative 4i. And let's continue our synthetic division. So now I'm just going to write the new coefficients we have from the above synthetic division, and it should even out at the end. Our final answer should, or our answer after this should have no i's, because the i's should all cancel out. So let's see. Let's do synthetic division again. We drop down the 1, negative 4i times 1 minus 4i. Oh, look at this. Add down. You're gonna see the i's are gonna cancel, and it should. So 3 times negative 4i minus 12i. Negative 2. Negative 2 times negative 4i would be 8i. 0. So so far we have a root of 4i, root of negative 4i, and now this is x squared plus 3x minus 2. We gotta find the roots here. Pause the video. Play it once you find these roots. So the equation was unfactorable, the x squared plus 3x minus 2, so you have to use the quadratic formula completing the square. I thought quadratic formula was easier because b was a fraction, and I didn't want to go dividing that by 2 and squaring it and having a bunch of fractions on both sides. So I use the quadratic formula, and your answer should be right here, plus or minus 4i, because that's what we got from the original question. And also, when you solve that x squared plus 3x minus 2, you get negative 3 plus or minus radical 17 all over 2. For the next question, find all the zeros of f of x and then write in completely factored form. I want you guys to start this one. So start it. I want you to list all the potential zeros, and then I'm going to show you a trick that's going to save a lot of time when you have a lot of zeros to choose from. That's going to show you which zero to use. So first, take a minute. Even though I'm going to show you guys this trick, you still need to show me all the potential real zeros and the work to get there. So list all the potential real zeros and play the video once you're done. So here is the list of all the potential rational zeros that we could have from this equation. But I don't want you guys to waste time. So how many zeros do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have a potential of 28 rational zeros. You don't want to waste your time checking all of those until you find 1 or 2, or maybe you can find all 4. So I want you guys. We're going to use the calculator to find the rational zeros we want to use, and then you still need to show work for a synthetic division. So in the calculator, let me bring up the calculator. So in my calculator, we're going to want to graph our equation. So go to y equals I already have it plugged in there with 6x to the fourth plus 41x to the third plus 42x squared minus 96x plus 32. So type that into the calculator. I'll give you guys like a couple seconds to type that in. And now we're going to check the graph out so we can find the zeros. So if I go to graph, there's our function. So it looks like we have two zeros here. Don't know if they're rational or not here. They could be. And then it looks like we could have a zero right here at around -4. And I know -4 is a potential rational zero from what we just did. So what I'm going to do, anytime you want to calculate anything on the graph, you press second trace, which is calc, and we're going to calculate the zero. So I'm going to go down to 0. So we could calculate this 0, we could try and calculate this 0, or, I mean, I'm just going to try and calculate the -4. It looks like it's bouncing from -4, so it looks like if it's bouncing, the multiplicity is going to be even, so maybe there's 2 zeros there. So left bound of that 0, press enter. I'm going to go to the right of that 0. It looks like it's around there. So make sure I go to the right. I'm definitely to the right of the 0. Press enter there. And then guess. Calibrate it. Oh, look at that. We do have a 0 at when x is equal to -4. So that's what I'm going to use for my 0 to synthetically divide. And I'm going to use -4 not once, but twice, because it looks like there's 2 zeros there. So let's go back to the notes. So there's what the graph looks like that we can tell so far. So we saw -4 was a 0, so I'm going to use that -4 for synthetic division. It looks like it's bouncing, so I'm actually going to use it twice, but here we'll do it once. So -4, then list the coefficients here. And do the synthetic division here. So we drop down the 6, multiply, add, and go ahead, pause the video, and complete that synthetic division. And we get 0 as a remainder. So obviously we know -4 is a 0, and then it looks like it's bouncing. So I'm going to try -4 again, because I think it could be a multiplicity of 2. So the factor could be like x plus 4, and that quantity being squared. So I'm going to try -4 again. It might not work, but we'll see. So it'll be 6, 17. I think it's going to, because I think it did bounce there. And 8, so we drag down our coefficients from the previous synthetic division that we just did. And go ahead, perform synthetic division on this, pause the video, and play it once you're done. We'll see if it works. And it did. So now we have our simplified equation that we now have would be 6x squared minus 7x plus 2 equals 0. Okay, so now we have our last factor is quadratic. So we could do completing the square. We could do quadratic formula. Or if it's factorable, hopefully it is, we can do factoring. So take a second here, find those last 2 zeros, pause the video, and play it once you're done. So it was factorable, and our 2 factors would be, our 2 zeros would be 1/2 and 2/3. So our answer, you want to write it like this, or I guess you can write it a couple different ways, but you want to make sure that you state that -4 has a multiplicity of 2. So that means there was 2 zeros at -4. So that would be our answer in completely factored form. Since there's a multiplicity of 2 on that 0 of -4, it'd be x plus 4 squared times the 2 factors that you got from factoring 6x squared minus 7x plus 2. So please use that calculator method to find the correct zeros for the function, but you have to make sure that you show this work right here. You have to show that you know how to find the potential rational zeros and use synthetic division on those zeros until you get a quadratic or a cubic that you can factor, or a quadratic that you can use completing the square quadratic formula. So you have to do all of those steps. It's just a little shortcut to see the what the actual zeros are. So let's go to the next page. So on the next page, it says, given 4 plus I is a root of the equation p of x, find all the roots of p of x. So we know 4 plus I is a root. That means what else has to be a root? 4 minus I, because it's plus or minus the radical, plus or minus that radical negative 1 in this case, which would be I. So if we know those are roots, well, I'm just going to start with 4 plus I. So 4 plus I is one of the roots, or the zeros, and then we would just perform synthetic division, exactly what we just did. So that would be 4, negative 57, 287. Give yourself plenty of room on this, because this is going to take up some space. And the same exact process. All this is more arithmetic. It's just using i's. So we would drop down the 4 and then do 4 times 4 plus I. So we do 4 times 4 plus I, and you get 16 plus 4I. Add vertically, so that would be negative 41 plus 4I. And this is where this question takes a while. If you do it all by hand, please use the calculator. It's going to help you. I know you guys can all do your arithmetic with i's. So you would multiply negative 41 plus 4I times 4 plus I, our root. And I would put that in the calculator and do that for every one coming up, because it's going to save you some time. So I want you guys find the simplify using 4 plus I, then simplify using 4 minus I. So pause the video, do that, and you can keep going if you want to, but I want to go over the next step after you do these two. So pause the video and play it once you're done with that. So after you do all of the arithmetic, this is what you should get. That second 4 minus I is a little bit nicer and easier because the i's end up canceling out. Big thing, it's so easy to make a mistake on this. If you know it's a root and you don't get a remainder of 0, think about another word for root is 0. And if you don't get a remainder of 0, you did something wrong. So go back and make sure you check your arithmetic. Sometimes, you're not going to see it and you have to redo the entire thing. That's happened to me a million times. So don't be afraid to do that. I know it's going to take up more time, but if you can't find the mistake, just go back and redo the entire thing. So now we have this factor that we have left. So 4x to the third minus 25x squared plus 19x plus 30. That would be so nice if this was being able to be factored by grouping. It's not. Can I use commuted property? No, I can't. Can't do anything there to factor by grouping. So if I wanted to, which we're going to have to, find the roots of this factor here, what could I do? Well, you're going to have to list all the potential rational zeros, and then use your calculator to see which one or two or three rational zeros there are, and then you can do the synthetic division with that 0, and then break it down to hopefully a quadratic that you could do the quadratic formula, complete the square factor with. So I want you guys to finish out this problem. Take 3-4 minutes, pause the video, and play it once you're done, and we'll go over and I'll show you guys the answer. So when I graphed it, so a lot of potential rational zeros there, but when I graphed it, I saw, 2 was a 0. I did my second calculated 0, left bound, right bound, guess. And then you get a nice quadratic equation here, which is factorable. And you might have chosen a different 0 up here. You might have chosen 5, or maybe you chose negative 3 over 4 to do synthetic division with. That's fine. You would just get a different equation here, but we would get all the same zeros at the end. So zeros would be negative 3, over 4, 5, 2, and then don't remember the two initial ones, the 4 plus I and the 4 minus I. So I wrote it as 4 plus or minus I. And those would be all the roots. So we use synthetic division with the i's, both roots, and then we see, hopefully we can factor the remaining factors. Sometimes you can't. Sometimes you can't do a factor by grouping, so you have to do use the rational root theorem to get all potential rational zeros. Use synthetic division on one of the zeros using your calculator to figure out which one it is. If you want to, I would definitely recommend it. And then we factor from there. So the checkpoint, I think this is the last part of the notes. Yeah, the checkpoint is just number 1 and number 2. These two are going to take a little bit of time. So pause the video, and when you're done, I will show you guys the answer up here. And that'll be it. Here's what I got for number 1. Big thing to start off here. If one factor is 3 plus I, we know the other one is 3 minus I. So that's what we use for synthetic division. And look at that. After we did synthetic division for both of those, we got a quadratic. So we could use the quadratic formula, because it was unfactorable, to solve. And here are my answers. And then number 2 was a little bit different because we had to set it equal to 0. And they don't give us any roots, so we have to use the rational root theorem to get all the potential rational zeros, and then use your calculator to see which ones it is. So I got 3, had a multiplicity of 2. You guys could have also, if you wanted to, you could have synthetically divided with -1 over 4 and 2 over 3. I just find that a little bit more difficult algebra to do. So I like to do the nice integers when we can't use that. So I just use 3. And then you get it down to a quadratic. And then you can I factored it because it's factorable, or you could use completing the square or quadratic formula there and get the same exact answers. So that's it. I'll post the homework. It'll be some parts of the classwork. And that's it. I will see you guys next week.